So the question looks like this. Imagine you're given a binary tree, okay?
Yeah.
And then it has some nodes. Does it look good here?
Yeah, looks great.
Okay. And imagine, by regular node representations, you have like node right, node left, and node value, right? And this whole tree can be represented as node 1, and all of the nodes are connected under the hood.
Yeah.
You will be given the root of this binary tree, and then you will be given something called to delete, which is going to be an array of integers. So not nodes, just integers. So you have, for example, 3 and 5, just like random values for now. What I'm expecting from you, so this will be your input arguments, and then as an output, I'm expecting from you to go through your tree and then delete the nodes if their values are contained in that to delete. So in this case, imagine we are deleting this 3 and 5. And if you delete, you'll see that 1, 2, and 4 are now separated from the rest, and then they're still connected to each other, and their root is 1. And 6 and 7 are orphaned and became separate trees. What you need to return is root of leftover subtrees. So what we have here is node 1, because it's still root, node 6, because it's now a separate subtree, and similarly node 7. So the order here is not important, as long as you return all of the roots. And yes, and that's it for now.
Okay. Does it binary search tree or just a binary tree?
Yeah, good question. So it's just the binary tree.
Just a binary tree. And does the numbers to delete, like the values, necessarily exist in the tree, or they can not be in the tree also?
Yeah, they might not exist in the tree.
They might not exist in the tree. Okay, so let me just rephrase the question to see that I'm fully understand it. I'm given some node of a binary tree, and then does the node the node exists, so it can be have no children, but the node exists, right? The input.
So do you mean those values which exist in to delete?
I mean, like I can edit the stuff.
Yeah, sure.
I can have like this node. It's a valid input, right?
Yes.
Okay. So I given some head of a tree, input values to delete, and I need to return all the roots after deleting the nodes in the to delete. In the to delete array. Okay.
Yeah.
So let's, for example, if I just need to delete one value, I will go around this. So I have this 2, 4, 5. So first, like I think, in order to make the lookup faster, I will create some. I will convert this array into set. So I'll have a set of delete. So I need this in order to just have all of one lookups. But now when I have the set of nodes to delete, I'm starting at the root. Since I don't need to delete the root, I will search its children. So let's say I'm doing some kind of BFS traversal. So now I will look at the left child. It's 2. It's not equal to one of my values. I'm searching the set. I'm searching 3 in the set. 3 is a value in the set. So let's say if I delete it or just mark it somehow, now what it created disconnects all the children from the set. So in this case, the output is like the same is 1, 6, 7. This is the expected output, right? If my to delete is just 3. Right?
Yes. Yeah.
Okay, so if I delete 3, Sorry, one more question. Does all the values into delete array are unique or they can be duplicates?
That's a good question. They could be duplicates, but for the sake, we can assume that they will be unique.
So for the sake of we can assume that they are all unique. Okay. So let's go back to the simple example of just 3. So if I remove the node 3, now I created 2 disconnected trees, 6 of 7. Let's say 6 and 7, and my original tree is still my original tree is disconnected from 6 and 7. So what I can do, if I start with this res output, I'm starting with the original node. If I don't delete it and I go BFS to 2, so 2 is okay. 2 is not part of the set. Now I go BFS to 3. 2 is a part of the set, so I delete it, and I attach his children to the result array. So, for example, if he had no children, the result would be just 1, right? Because we have still just the original tree. So this is the result, right?
Yes.
Yes. Okay. So this is in the simple case. Let's see what if we have also 5 in the to delete. So in the set we have 3, 5. After we disconnected 3, we continue our BFS and we check if 4 is in the set, is not. Now next in the BFS we check if 5 is in the set. This is holds true, so we disconnect 5 and attach its children to the result. So since it has no children, the result is still 167, and in 6, then we continue with BFS for 6, 7, and they are both not in the set of nodes to delete. So we end our iteration and return 167. Let's see. I finished this example, but let's say 5 has some children. Let's call them 8 and 9. Those are children of 5. So if we disconnected 5, we would attach his children to the result array. So you said that the order doesn't matter, right? The order of the output. Yeah. So we attach his children, and 6, 7 are the same logic. So we had 1, this subtree, 8 subtree, 9 subtree, 6 and 7. So this sounds okay for me. Yeah. Do you have any question about my logic? It makes sense to you?
Yeah, all makes sense.
Okay. Regarding the time complexity of this solution, so I need to convert the set. So the tree has n nodes and tree has, let's say the tree has n nodes. So time of creating the set is O of n, creating the set. Then we need to iterate BFS. So we're iterating over all the values. So it's O of n iteration plus lookup of O of 1. So it's still O of n for the iterating. Deleting, so deleting is O of 1. And so overall time complexity is O of n, where n is the number of nodes. The number of edges are like the same as the number of nodes because it's graphs with no cycle, connected graph with no cycle, so it's the same. And space, we have array, we have the set that is O of n. We have the result that can be possibly like half of the nodes. So let's say, so it's also O of n space. And for the BFS, we need to have a Q that is also O of n. So overall is also 3 times O of n. Space and time complexity are both O of n. Okay, that
Great.
sounds logical.
Yes, sound good. Do you think either of these can be improved further?
Let's. I'm thinking about the space, because for time I will have to iterate over all the nodes no matter what, so it will stay over n. But for space, um, if I'm doing a BFS, so like the numbers in the queue would be half of all the values if the tree is balanced, so it will be over n. But let me think if I will can solve this problem without BFS, so without the queue of BFS. So the input is just the input is the head of the tree away to delete. I can give up on the set and search with inside the array of the to delete values. Now okay. A question: does the to delete array it bounded or it unbounded in the size this to delete array?
Yeah, so it's going to be bounded. So it will be limited to the number of nodes at your tree.
Okay, so the search in the array is still open if it's unsorted. I assume it's like general array not sorted.
Yeah.
So yes, so if I give up on the creating set from the array, I can get rid of the oven space. I still have the one of this queue of the queue of the BFS, but now the searching the time complexity becomes much higher, so it becomes oven squared, because for each node I need to search in the array, so it's oven squared time, and I still have oven space due to the BFS. So even like if I would get rid of the BFS, I still be in oven square time. So I think it's better to have oven time and oven space than oven square time and oven space. So
Yeah, so if you were to choose between these two options.
I will, yes. So if I would need to choose between those two options, I will choose the current one that is on screen. So oven time and oven space both.
Yeah, sounds good to me. If you have any additions, feel free to add, but feel free to start coding otherwise.
Okay, I will just copy it. Which would be converted to Python.
Yeah.
Okay, so
Oh, this is strange. It didn't save, right? The previous.
I copied it. I copied it because I wasn't sure if it will be copied. Okay, so how it's called this function? So subtrees, and it takes root and to delete. Do you want me to also implement the node class?
No, like it's fine for you to just like write the definition for node class, like oh, actually you don't even have, I mean, yes, just write the general.
So what do you mean by general? Just write the class?
Yes.
Okay. Sorry. And yeah. So self-val, so self-val equals value, and self-left is none, and self-right is also none. Okay. This should return array of nodes. Okay. So I need to convert this to set since it is array. Fortunately, it's quite easy in Python to do this conversion. After that, I need to create a queue. Queue of the root. Create queue from the root. And I need the result array. And while the queue is not empty, I need to pop the node. So pop from the left because this is a need to use it as a queue. So pop left, and I will push to the queue is children. So queue push. If it has node dot left, I will push its left child. Same for its right child. If it exists, I will push it. No dot right. And I forgot, and I need to add. So this is for the BFS. Now for the logic of creating the output of the function. So if the value of the node is in the subtree, is in the to delete set, in to delete set, what I need to do is to push is both children. So I need to append is right child. Let's be consistent. We start with left, so let's be left. And sorry, should be. I need to return the nodes, not the values. Okay, so I push the node dot right, append node dot right, but I'm missing something because in the start I need to have the initial node, but if I'm disconnecting it, if the initial node is into delete, I need to remove it. So what I can do is I can append the root and if root dot value, if root dot value is in the to delete set, I will immediately remove the root because it's not part of the result. So just remove the first value. So if I'm deleting from the set I'm appending, and let's see if I'm missing some logic. Then return the result. it would be okay if I will try one against some test cases, because it will be easier for me to see if I'm missing something or have some bug.
Yeah, sure.
Okay, so initially I wanna try just the one root. Like this is my input, this one. So my to delete set is 1. Q is 1. Root.val is in to delete. I need also to delete. So let's say to delete set is empty. So to delete, sorry, to delete is empty. This is the empty array. It's part of the input, not the variables. And so root.val is not in delete set, so we don't pop. Q is not empty. Q is not empty, so we pop 1. So node is 1. Q is now empty. Node.left and node.right are none. Node.val is not in the delete set. Forgot the initialize the result. So we return the result 1. Let's say if we have to delete, let's say we have this problem from before, and to delete is 3.5. 3.5. To delete set is 3.5. Q is 1 root. Res is the root, and it's not the value is not in the delete set. Sorry, this is 3.5. So we start with node 1, and we pop it. Where's the Q? And we push left and right. So we push 2, 3. Node.val is in the delete set. So node.val is not in the delete set. So we continue to next iteration. We pop from the left. So we pop 2. And now the value is 2. We append these children. So we append 4 and 5 to the queue. Node.val is not in the delete set. So we continue to the next iteration. We pop. I'm popping from the left. Yeah, pop from the left. So node is 3. Node is 3. Append is children 6 and 7 to the queue. Now it's in the delete set. So if is in the delete set, we append is children. We append is children. And next iteration 4. 4 has no children, and it's not in the delete set. So next iteration we pop 5. 5 has no children. It is in the delete set, but it has no children, so we don't append to the res. Same for 6 and 7, they are not in the delete set. So we finish iterating and return the result 1, 6, 7. Okay. Let's see. If I miss something in the logic, let's say I have node 2 and 3, does it still work? I start with 1 in the result, then it should be 1, 4, 5, 6, 7. Yeah. So yeah, it still work. Okay. So I think it's okay. If you have any question or you want to point something.
Okay. So the expectation here is to have a working code. Will we be able to write like a main function calling this function and then provide
Yeah.
couple of here? Yeah.
Yeah. So from actually I don't remember where to import DQ from. Can I look it up or
Yeah, sure.
okay? DQ in Python. It's from collections. Everything is from collections. Okay. So the tree, how do I define the node here? Is node. This is you wanna print the subtrees with tree and to delete. Let's say it is empty. In this case, I expect one. If I delete this, if I delete it, I expect an empty set. Now let's create some children. So root dot left. So I will copy paste it because it was a good example. Copy paste it. No. Okay. So node 2 node right, it's node there's 3. It is not so it is root and root left root left right. This is 4 and 6, 4 and 5, sorry, not 6, and vice versa. So this is node right left and node right. It is 6 and 7, and we're passing 3 and 5, passing 3 and 5, not 4, and we expect 1, 6, and 7. Can I run it?
Yeah.
Now the object is not iterable. In line 38. Line 30. Maybe I cannot convert it any the values. Okay. So I'm trying.
Okay, so if your object is not iterable, what are the alternative ways to put things into deck?
Yeah, so I can create a queue and append
Mhm.
it. Append this root. Okay, I will run it again.
We are.
Sorry, this is, I think it's append. Yeah.
Okay. Yeah.
This is reset it.
Okay.
I need it's object. So
Yeah.
I will take the result and print it. So where the print issue. This should take 25 and this should be not, I don't need this print. This one, this is empty, and this is 167. Is it running? Okay. Okay. It as I expected. That was as I expected.
Great. So, do you think we can test with more edge cases now? What could be a potential edge case for this problem?
If let's say I want to remove a leaf, or am I testing it? Yes, I'm testing with 5. I'm removing a leaf, but let's say I'm removing 2 children. So in this, I will remove 2 and 3. I will expect this. So let's testing removing 2 children.
You can actually directly modify. You can just do this here.
Deleting 2 children. And other than that, if I delete 2 and 3, this is deleting 2 children. Deleting leaf, I'm testing. Deleting the root, I'm also testing. Yeah.
So what would be the expected output in deleting 2 children?
Yeah, it should be 1, 4, 5, 6, 7. This should be the output.
Okay.
So let's run it. I should have, this is the result. I just needed to put a delimiter between 2 points, but this is the expected results.
Okay. More edge cases that you can think of?
Let's say I remove, this is my tree, and I remove 1. I should expect 2 or 3.
Okay.
And I think it's a good cover. It covers all the cases I can think of. You want me to run it?
Yeah.
Okay. So I delete 1 and I expect 2 and 3. Okay. As expected.
I want you to think about more edge cases if possible, like 2 more.
Yeah, sure. And deleted the root. This is okay. Deleted the root with children. Deleted the leaf. And deleted the 2 children. I deleted 2 children. Let's look at the input. So input is a value to delete. I tested if to delete is empty. Let's say if to delete consists of values that are not in the tree. So let's say to delete as a 10 here. sorry, this is not the to delete, this is the result to delete have 1 and 5. And what more inputs I have? The to delete and the array of nodes. Let's run this to delete with 1 5. Expect the same result. Yeah. This I don't have any other edge cases coming up to my mind currently.
Okay. So what happens if the tree provided to you is empty?
So let's say I provided an empty tree.
Yeah.
If I provide an empty tree, so the result will not be correct. I have a runtime error because I will check the fruits.val. So if I provided an empty tree, I need to return empty array because I cannot. There's nothing to remove, so there's no subtrees.
Yeah.
Yeah. So let's test it. So let's have root equal to none, and we delete whatever. We expect empty array. Actually, let's print the result because it's not. Let's print the result. It should be an empty array. Yes.
Okay. Can you think of more edge cases, or is that all?
I don't have any more edge cases coming to my mind.
Okay, so what happens, for example, if we're gonna delete some node and its immediate child? So let's assume in this case it's gonna be 2 and 5.
2 and 5.
Yep.
So let's say delete 2. I push his children. Yeah. So in this case, my logic will not be correct because 5 will be in the result set, and it should not be. So actually, I need to move this logic into here. So if the value, if the node dot value if the node dot value is into delete set, so let's create a res. Let's create a res that have converting the result into a set, so I can pop from it more easily and delete from it. Sorry. So if node dot value is into delete set, so it should not be in the result. So we delete it we delete the value. Also remove, not delete, it's remove. Remove the node. Remove the node. And all the logic stay the same. So let's take this tree. Let's have this simplify tree. So I have 1, 2, 3, and I remove 1 and 2. I expect the result will be 3. So node dot left. For node so expect the result to be just 3. So res it should not be append, it should be res dot add, since it now is set, and we need to return an array. So I think this should work. And return an array. Yeah. So let me run it. Yeah. So this is return 3. So can I maybe reset it one again so it will be clean? Yeah. So it returned 3. So yeah, this is the edge case I didn't thought of.
Mm-hmm. So what happens if 2 has children below it?
If 2.
Yes, so imagine it has something under this, like, yeah. Mm-hmm.
And we remove 2. So in the iteration in the queue, so we pop left. 2 is already in the delete set. Mm-hmm. So maybe 2 is in the delete set. We move 2 from the result, and it has children. It has 4 and 5. So we append 4 and 5. 4 and 5 are not 4. We push 4 and 5 for the queue. We iterate over 3. So at the start, it's like this. The node is 1, 2. Sorry. We delete 1, so it starts with 2, 3 as the result. Now, when we iterate over 2, we remove it from the result and append 4 and 5. Mm-hmm. We iterate over 3, and since it's not into delete set, we do not do anything because it doesn't have any children. And same for 4 and 5, they're not in the delete set, so we return them. So let's run some test case. So that left and that right equals to 4 and 5. Mm-hmm. This I reset. I delete 1 and 2, and I expect 3, 4, 5. The result. Yeah. 3, 4. Great. Yeah. So the order doesn't matter. So it's.
Mm-hmm. Yeah. Sounds good. So I think with that, your solution is now complete. So, okay. So if you had, let's say, like more time, would you change anything in your code or approach, or would it remain the same?
I don't have anything coming to my mind right now.
Mm-hmm. Okay. Sounds good. Okay, so we can wrap up the interview part of the session. So I've written some feedback, and then I'm gonna brush it up a little bit and then like put it into the feedback session after we finish this. But you had other questions related to the actual Google interview, right? So you can ask them now, and then I will send feedback after this.
Yeah. So regarding the scoring way of Google, I read that like they have 3 metrics. So problem solving, coding, and communication. So what are like the kind of low hanging fruits that a lot of candidates candidates fall that like I can easily fix.
Mhm.
So the common mistake that a lot of candidates fall in.
Okay, so I think like a lot of candidates treat interview as if like it's a one-sided evaluation, but as you might know, the interview is more like a teammate discussion. So I think you did pretty well on this kind of in this regard here. So you kind of made sure to explain things and then just like jump to the next session, and then you will kind of practically guiding the whole session, which is good because most candidates just wait for the signal from an interviewer to do what is next. So they ask for the things from the interviewer. I don't know, like, oh, could you provide like test cases? Oh, should I like start? Should I begin? And so on. So it feels as if really like it's kind of a one-sided evaluation. And because like depending on the level you are aiming for, you should exhibit certain skills. Like for example, if you're like L4 plus, you should be already kind of acting independently, like solving your problems and asking for minimal directions. So that interview is also assessing that part as well. I think you did pretty well because like I didn't have to provide many things here, and then you kind of like when you were stuck, we were pretty much discussing things, not like me on that kind of like I'm blocking you. And so I believe this is the low hanging fruit, like the way how you treat the interview session. Regarding the problem solving part, most candidates forget to cover edge cases first, which you also didn't in this session. And as you might know, edge cases are very important in terms of structuring the code, making sure that you took the right approach. And luckily, your approach was quickly amendable to allow to handle these edge cases after coding it. But most candidates actually end up writing a very rigid code, which ends up being very messy after debugging, and it lowers their score by a lot. Because depending on level again, you always need to look very into the future and make sure your solution handles different possible cases. So I think these two are very important. One of them is low-hanging, the other one is like, let's say, like a basis that you expect from good engineers. And most candidates, they don't like exhibit this two, in my case.
Yeah, cool. Just one more small question. I saw that like in the interview to Meta, like I need to debug to run my test case like a debugger. Does it also apply to Google, or it's less important than thinking of edge cases, like running the code like a human debugger?
So it depends on an interviewer. So some parts of Google do provide you an actual link to an IDE, like for example, DeepMind part of Google, or like Google Research, they also do this. But I believe like main Google, like if you haven't received in your calendar link any links to IDs, that means most probably your interview is going to be held in Google Doc. And then there you write your code as if there is no IDE. And then most probably you're not expected to run a fully running code, debug it fully, but any kind of approximations to that is very much praised. So if you do like dry run through, and then if you see any kind of possible errors, you could like fix them on the fly, and then like dry running through it, and maybe like showing that you're testing things maybe in comments, or like as you did here, like by creating edge cases and programs under your solution is very much appreciated. And if you're not sure about the actual approach, ID or not ID, you can always message your recruiter. But my hunch is that if they didn't provide anything in your calendar link, it's going to be Google Docs.
Yeah. Okay, sounds great. I would like to have like a more interview with you if it's possible.
Oh yeah, welcome. Yeah, I will mark it like or open for rematches. Yeah, should be done.
Okay, sounds great.
Welcome and good luck in your interview.